Hi, so now I want to talk about parallel circuits. If you've seen the series circuit video that I made, you remember that in series circuits, current was constant. So you had the same current through every point of the circuit. In a parallel circuit, which schematically looks like this, voltage is constant. So every component in the circuit has the same voltage across it. Now, you might ask, how do you do one of these problems? Here's where I'm going to differ quite a bit from the author. The author in every one of his problems likes to find RT first. RT is a real pain to find in a parallel circuit. Essentially, it's the reciprocal of the sum of the reciprocals gives you the total resistance. Now, I found that even people that are studying to be electrical engineers, when they learn that the first time, they make mistakes putting it in the calculator. So, do not solve for RT for a parallel circuit first, unless you're absolutely forced to, which I won't actually make you do in this particular class. If we were taking a circuits class together, yeah, I would do it, but not in this one. So, what I want you to start with is recognizing that each one of these elements has the source voltage across it. Since it has the source voltage across it, we can use Ohm's law to find each one of the individual currents. So, recognize all the voltages are the same. Then use Ohm's law. So what we're going to do is we're going to take the source voltage, divide it by each one of the individual resistors, and lo and behold, we will have the current through that branch. Once we solve for all the branches, remember Kirchhoff had a voltage law? He also has a current law. So basically, the current law says, basically, it's kind of a silly law, but whatever goes into a junction has to equal what's coming out of the junction. So we can find the total current by adding all those individual currents that we just calculated before up. Once we have done that, now you can use Ohm's law to find the total resistance. So the total resistance is simply the voltage source divided by that total current you found by calculating with Ohm's law all the individual currents and then adding them together. Once we have the total resistance, well, at that point, we've got all the currents, we know the voltage is the same, we can calculate the powers just like before. Same power formulas, any power formula, whichever one's your favorite works. Again, I always like to use V times I. Make sure you use the right V and the right I. So for total, it's the total, which is the same throughout in a parallel circuit, times the total current. For each one of the individual resistors, it's the source voltage times the current through that resistor. So, individual currents will be directly proportional to voltage, but inversely proportional to the resistance value. So the smallest resistance value will have the most current going through it. Simple, right? The other thing about parallel circuits, with a series circuit, I showed you the Christmas lights in the last video, one element opens, everything's gone. If an element opens in a parallel circuit, there still is a path for the current to flow through the other elements. So the total current actually goes down. Your house is wired in parallel, Every outlet in the house has the same voltage across it, And if one light goes out, circuit breaker blows, everything else still works in the house. It'd be kind of fun if it was in series, Then everything would go out when one volt went out. So there you go. You now know everything about parallel resistive circuits.